Hi all, welcome to my channel. In this video, we're going to discuss about one of the most important concept in concurrency, Java logs. So this is the ongoing videos on like list of videos on Java concurrency. We also talk about like how to create a thread, what is producer consumer problem, atomic and volatile, synchronization, blocks versus basically class or synchronization, everything very in depth. If you don't watch the videos, if you miss those videos, I'll put the link in description. So please go and watch. So those are very important concepts and building blocks for Java logs also. Like so, here Java logs is very depth concept where we have different type of locking and we need to understand like when to use when also, and we'll discuss everything in detail with the programmatically, and we'll also discuss about like real world scenarios also when to use when. So what exactly Java locks? Java provides various locking mechanisms through a package which offers more sophisticated thread synchronization than basic synchronized blocks or synchronized keyword. So which I already covered. What is basically synchronized keyword and applying on the class level or method level, block level, object level synchronization. So now let's dive deep into the concepts of different kind of locking strategies like reentrant lock, read write lock, and semaphores. What is reentrant lock, right? So reentrant lock is a mutual exclusion lock with some basic behavior, the same basic behavior and a semantics or implicit locking, whatever is in the synchronized keyword with the enhanced capabilities, right? So a name suggested here that you need to understand the reentrancy. Like the reentrant lock is reentrant, meaning it allows the same thread to basically to hold the lock again. Ideally, like whenever to acquire this locking strategy, right, it will lead to deadlock. That is basically preventing with the help of reentrancy. Like so, meaning it allows the thread holding the lock to acquire it again. Let's go into very in detail of what exactly reentrancy. So a lock to be acquired by multiple times by the same thread. There is a situation that a single lock can be acquired by multiple times by the same thread itself. Like same thread only locking wants to lock multiple times. Like when a thread acquires a reentrant lock, it holds what exactly it will do. Like whenever, for example, think in a situation like how deadlock, right? So basically, we acquired a lock and we basically waiting to the other lock, right, or the other resource, like. But here that is also acquired by the same thread. Here, what should happen? It should ultimately go to the deadlock situation. But because of the Java reentrancy, right, this is not happening, right? Why it is not happening? Let's see, like Java. So the reentrant lock holds the called count. So every time a same thread acquires a lock, it will increment the count, and every time a lock is released, it decrements the count. The lock is fully released when count reaches to 0. The lock released on an object when a count reaches to 0. So this feature is particularly useful in situation when a method calls the another method, but the another method also requires the same locking, like same thread lock. So, so which is the ultimate reentrancy, right? With a non-reentrancy lock, this scenario would result in deadlock, as I just explained before, right? So this is how what is basically reentrant lock. We basically discuss about like a demo also, or let's see the demo and comes to the read write lock. Yeah, Java locks, right? Now let's create a reentrant lock demo. Let's assume reentrant lock demo. So here what you can do, here you can basically create a lock. You can create a reentrant lock equals to new reentrant lock. So let's create a method called outer method. Let's create a public void outer method, and same time public void inner method. So and yeah, main method. Let's create a default constructor. I think default implicitly there. Like reentrant log demo. equals to new reentrant log demo. So now basically let's have whenever a object is trying to enter this outer method, let's create a lock, reentrant log dot lock. So now let's perform some operation. Let's perform a wait. It is basically performing some hard computation. We'll wait for 1 second, and we'll catch the interrupted exception. Yeah. After waiting for 1 second, let's say the same thread, same basically this inner method also wants the same locking. Got it, right? That is the most important thing. So you basically call the inner method. So here also you can easily perform reentrant log dot lock. Here a counter will be incremented by 1. So initially 1, now it will become a 2. You can also perform some large computation operation. Here no need of any inner method. You can just simply ignore. So finally either throw exception or it not throw exception. Whenever you're basically locking, it is always good to basically release the lock in the finally method. This will basically, irrespective of exception or like success, this will always execute like. So yeah, you can perform like basically let's say outer, just for simulation purpose, outer method. Let's say inner method, right? So now reentrant log dot outer method. If execute, what will happen? Nothing will happen like. So it will execute as it is like without any issues like. First it will go to outer method, it will call the inner method. Here also it will acquire the same locking and wait for one. It will bring the inner method and wait like. So if you see like with how this outer method, inner method happened with the help of reentrancy. For example, if reentrancy is not there, here we basically locking on the same locking and we call the inner method. By the time also this is also got locked, right? So here it would lead to deadlock situation because of like we are locking with the same object. We are locking because of this reentrancy. When an object tries to lock, when an object tries to acquire the same lock again, it will provide like without any issues, like without no deadlock will be happen here. Now let's discuss about like read-write lock. So read-write lock maintains a 2 pairs of lock. We already discussed in a previous video, but here we'll discuss more. One is basically read lock and second is basically write lock. So the read lock can held simultaneously by multiple reader threads, but write lock should be exclusive. Like there is so as long as no writes happened on a particular object, objects can read the data concurrently. But whenever something is writing, some resource is basically writing, everything will go in a blocked state. Everything will basically wait till the write should be completed. So this will basically important when you require you want to support a high concurrent applications where you want to unblock a reads over writes, right? So whenever writes only, it's an exclusive lock. Whenever during reads, you can simultaneously access the data like. So when you have high ratio of read operations to write operations and require concurrency for reads. Generally a reads doesn't require concurrency, but if you require a concurrency, then you apply this read-write lock, and it will make sure that writes whenever a thread accesses the write operation, everything is stopped, everything will be blocked. Wait for writes to be unlocked to perform either reads or future writes. What is the advantage of synchronized keyboard, right? So it improves the concurrency by allowing multiple threads to read a resource as long as it's not been written, which can improve the performance of a synchronized method that locks access for all the threads. So whenever you apply synchronized synchronized one on an object level, it will lock irrespective of read and write, right? That's basically performance degradation. But when you apply this read-write lock, it will not block you on the read level, it will only block you on the write level. That improves the concurrency and it will also generate a more throughput as well. And also flexibility, like separate lock of read and write operation provides a more control to the application to handle like this locking strategy and controlling the resources. So what is the real world scenario, right? Escort tracking system. So for example, ClickBuzz or any like websites where basically multiple people constantly read the data, right? So and also only one person will basically write the data, or like couple of people, like, so from the maybe who are in stadium, or like who are managing this whole broadcasting, right? So here you can apply the read write log. So the reads requires a concurrency, but it will not block. But whenever someone is writing, right, it will block everything. So till the write release the lock. So but writes to updates the score are less frequent. That's why the read ratio is very high compared to the write ratio. So when read write locking is very helpful to allow multiple threads to read the score without blocking each other, as long as no thread is basically updating the score. So this is basically one example of read write locking. Let's see the demo before going into Semaphore. Read write lock demo, right? Now let's define a, let's say, read write lock. Read write lock. Lock equals to new read write lock. Yeah. Now let's define a score also. Score equals to 0, ClickBuzz score. For example, maybe set score, right? Maybe like, let's say, update score. Maybe you can say a new score, maybe, right? You're updating a new score. Here you can apply the lock dot write lock. You can apply the write lock. Sorry, you can apply the write lock, and you can happily update the score. So score plus equals to new score. Once you updated, you can basically release the lock, right? Write lock dot unlock. But always make sure some issue will happen in between, right? Always make sure that put it in a try block. So which will make sure that you can ignore for now exception, but always make sure that release the raw logs in the finally, like this will always make sure that logs will be released once acquired. So now you basically, now when comes to read, right, get score, you can perform log dot read log dot log. You can basically try, okay, this will return the integer, return score, and in the finally you are releasing the log dot read log dot unlock. Now in the main method you can happily create a demo, like read write log demo. So demo equals to new read write log. So demo dot update score. So for example, let's create a thread equals to new thread. Update score, maybe for int I equals to 0, I less than 1000, I plus plus. Update the score of I, maybe, and it's doing by multiple, let's say thread 2 also trying to update, and now thread 3 is basically trying to read. Let's say 1000 times you can basically get score. You can just print system dot out dot println. Yeah, now for example you can start a thread 1, thread dot start, thread 2 dot start, thread 3 dot start. You can, you can basically wait till all the threads basically join, completed it's working. Thread dot join, thread 2 dot join, thread 3 dot join catch interrupted exception, maybe interrupted exception e. Yeah, if you run the program, what will happen? So all the threads basically parallelly so two threads parallelly writing and one thread parallelly reading. See, you're sure, right? Like you can just move the hierarchy as well, that doesn't matter. Okay, sorry, here starting a thread. So thread 1 is basically also updating the score, thread 2 is also updating the score, and thread 3 is constantly reading the score. So here only one thread, whenever writing, every thread will basically blocked. Whenever writing this thread, this one basically blocked until unless it releases a lock, it won't happen. Like for example, you can see the simulation as out writing block. For example, writing unblock. You also reading reading unlock, but here we can say reading checks for writing. So let's simulate also thread dot otherwise it's very fast, right? Thread dot sleep 100,000. Yeah, here also thread dot sleep 1 millisec 1000. You can surround it in try catch. Yeah. Now if you run the program, you will see write block, read checking until unless write unblocked, right? And again read unblock. So until unless write unblocked, you are not able to write anything. So if you see until unless basically writing unblock, here reading is basically checks for writing, right? Now because of write block or until unless write unblock, you cannot access the reading and you cannot update you cannot basically get the value. So here basically writing is happening and get the value. Here your whole stuff is going on, right? This is how basically it's happening. So first write is acquiring a lock. So meanwhile other thread also start reading, but as it is writing, it is it's updating the value, and basically it released write unblocked, and also parallelly also another thread also start writing, because there are two threads, right? It's also unblocked. Then we're actually going into the reading and reading unblocked, and we're printing the value. See how it's happening. So in a multi-thread environment, in order to simulate the stuff, you should always use the threads which will sleep value, which will basically help you like to understand how this read write lock, reentrant lock, any kind of things, how it's working like. So I hope you got very clear about like how this write exclusively blocking the whole stuff, reading also, and while reading nothing was blocked. Yeah, this is what about reentrant lock, like read write lock. Now let's discuss about last concept, semaphores. Semaphores is also a thread synchronization that controls the access to shared resources only, but the only difference basically using of a counter. So for example, whenever you create a lock, we'll give the how many total threads can access this particular resource. Until unless it will basically allow to access that resource. Once the thread count reaches to 0, until unless unlocked by someone, no other thread can basically access that one. It's a kind of a mutual exclusion with the help of with a counter. So if you keep 100 as a thread count, 100 threads can parallelly access this one, but if you are all 100 are occupied, until unless if 101 is coming, until unless something is from 100 out unlocked coming out from that semaphore counter, the 101 will basically access, otherwise it also blocked. So semaphores are often used for to restrict the number of threads that can access a physical or logical resource. What is the advantages over synchronized thread? Control over resource allocation. It allows you to specify the exact number of threads that can be accessed the resource simultaneously. This is how you can basically block the number of threads can also access, right? And also flexibility. It can use to implement it can use to be implemented by other synchronous IDMs like signaling mechanism between threads. So whenever a thread unblocked, a new thread will come into picture. Otherwise thread will go into waiting state, right? It's also kind of a signaling mechanism. It was the semaphore process signaling mechanism as well. So what is the real world scenario? A printer service, right? For example, you have a three printer service configured. So someone is basically printing. So someone basically parallelly multiple laptops connected for a three printers. So, anyone can give the printing, right? So so three people can give parallelly for the printer operation because we have three printers. For example, if more than if, for example, 5 people are giving, so 2 people should wait at least to get the 2 free resources. We have only 3 threads, so only 3 threads can only access. So printer service where only limited number of printers are available. The semaphore restrict the number of concurrent printing jobs to the number of available printers, thus ensuring that no more threads can access the resource than there are printers. So this is how basically we can use a semaphore to utmost important way. Like, so before going into summary, let's see the demo video about this semaphore demo. Semaphore demo. Let's create a semaphore lock. Semaphore. Let's create a semaphore. Let's mark it as a final. We'll initialize the number of threads it want inside the constructor. Like, so not this one. And number of threads. So equals to new semaphore. You can give the, for example, number of threads, right? You can give number of threads here. Now simple. While you want to access basically public void printer. So basically you can perform. You can basically it's semaphore dot. You can acquire a lock. You can basically acquire a lock. Once you acquired, this should be under interrupt exception. Yeah. Anyway, you acquire a lock. You can basically perform. Yeah, we can also keep in a try catch block. And we can remove this thread exception. We can keep under try catch block. Anyway, let's add this catch clause, right? Now finally also we need to remove the lock, right? We need to finally here. Before that, let's simulate system.out. Printing. So printing. You can simulate with the help of thread.sleep, and finally you can basically semaphore dot release the lock. So you can simulate how many threads are parallel accessing, right? Thread dot current thread dot get name. So this thread is basically printing currently. Likewise, you can check how many. And yeah, printing. Now basically let's define a main method and let's give a semaphore demo. Semaphore demo equals to new semaphore demo. Let's have a three printers for now. Now what you can do, you can basically create a thread for int I equals to for int I equals to 0, I less than 10. I have 10 printers. You can thread thread equals to new thread. You can basically access this semaphore demo dot print, right, and thread dot start. So you're accessing I can do this one also, that's not a big deal. So now if you execute, right, at a time only, even though we are parallelly trying to access 10 times sending this printing job 10 times, but only three threads can only access, like thread 1. Okay, well, let's go into released, right? Let's see released. Now let's see. See, only 3 threads are, then only released 4 thread coming, then released 7 thread coming, then 2 are released, then 2 new threads are coming, then released 9 thread is coming. So once everything is coming, everything was basically released and exit out from the process. So this is how you need to simulate, like how this is actually working, right? We are acquiring a lock and we are simulating this one, we are releasing. So at a time 3 threads will come, so some is basically still in process, that's why it is blocked. Something is released, either thread 1 or maybe some thread is basically released and new thread basically acquired, and that is all something, and then some is released, 4 is basically acquired, some is released, other acquired. So here 2 are released, now 2 are basically acquired. So this is how basically controlling the resource allocation through fixed number of threads accessing this shared resource through semaphores. So I hope you understand everything. Now let's say summary. So reentrant locks offer more flexibility and better performance in some scenarios compared to synchronized. Using it when you need to advance it, which is like with the help of reentrant locks, you can also perform the timer locking also, lock waits also, lock pollings. You want to acquire a same thread again, wants to lock the same object again, you can perform with the help of reentrant lock. Read write lock, as we discussed, when you have infrequent writes but a very high concurrent writes, then use this read write lock, like, so it will always taking care about concurrency thing. And next and also it will improve the performance of read heavy operations. Next, semaphore rate allows a specific number of threads that can access the particular resource at the same time. It is useful for controlling the access to a pool of resources such as database connections or a printer. We'll see in the future videos where thread pools also will come into picture. That's where we'll basically discuss in depth about like a fixed number of pools or like cache pools or like all those things. But in the locking mechanism, these 3 are very important powerful locking ways provided by Java, like reentrant, read write and semaphores. In the next video, we'll discuss about very in depth about how to define our own concurrent hash map, building our own concurrent hash map and understanding from the existing concurrent hash map. So I hope you like the video. If you have any doubts, feel free to ping in the comment section. We'll soon meet in the next video. So only thing you have to do is basically follow my videos, get good in basically Java, and please like and subscribe to my channel. We'll soon meet. Till then, bye bye.